So hi guys, welcome back again to Derive. So I'm Engineer HB. So we're still on the topic of chapter 3 which is shafting. So naglagay ako ng part 2 for bending, torsion and angle of twist problem in order for us na mas marami pang mapraktisan na problems. So kung gusto nyong mabalikan yung mga formulas kung bago ka sa ating YouTube channel or on this topic, so balikan mo lang yung part 1 of this video kasi hindi na ako magre-review ng formulas kasi nga part 2 na ito. So halika, let us start solving past board exam problems. Okay? Ayan. The power that can be transmitted by a spindle of 55 mm diameter running at 1,200 RPM and allowable stress of 5 megapascal is equal to, so the question is looking for the power that can be transmitted by the spindle, or a shaft of 55 millimeters diameter. So lagay na natin dito yung 55 millimeters diameter. So running at 1,200 RPM, so lagay na natin 1,200 RPM and allowable stress, sabihin natin SS or shear stress of 5 megapascal. So the question is looking for the power. Okay, so we all know the formula for the power is equal to torque multiplied by the shaft speed divided by a constant, So meron tayong dalawang constant which is isa for the metric, isa for the English. And if you're going to look at the given, we have the millimeters and the megapascal. So matic, we have a metric system here. And we all know that meron tayong 9.54910 raised to 6 na constant basta ang power natin is in kilowatts and our torque is in Newton mm and our shaft speed should be in RPM. Okay, so ayan, we have the torque, the N, and the constants here in order for us to have the power. So meron na tayong given na shaft speed which is 1,200 in RPM. The question is, where is the torque? Okay, so here's the thing, meron tayong given na allowable stress dito or shear stress. And we all know that the formula for the shear stress under torsion is equal to 16T over pi d cube. So meron tayong shear stress which is 5 megapascals or 5 Newton per square millimeter is equal to 16T divided by pi times 55, which is our diameter here, cube divided by millimeter cube. Or times cubic millimeter. Kasi inube natin yung millimeter nung unit nung diameter which is 55 mm. So the units that will be cancelled is, ayan, isang mm, makakancel ito. So may tatlo kang mm dito, may dalawang mm, so may matitira ka pang mm dito, which is pag cross multiply, our torque will be in Newton mm, which is perfectly fitted here. Kasi Newton and M yung hinahanap nating torque. So our torque here will be cross multiply 5 times pi times 55 cube divided by 16, which is 163,338.27 Newton mm. So direct sub here, it will become 163,338.27 Newton mm times 1,200 RPM divided by 9.549 times 10 raised to 6. Okay, so that will become, answer mo kanina, huwag mo naburahin, times 1,200 divided by 9.549 times 10 raised to 6. That is equal to 20.526 kilowatts. So this is the answer. So meron ba tayo dito? A 10.5, B 20.5, C 25, D 30. So the nearest answer is letter B, 20.5 kilowatts. So the answer is letter B. Okay, so proceed tayo sa second question. And if guys may narinig kayong music the background. So medyo nagpapatugtog ang ating neighborhood. But hayaan nyo sila, no? Mas malakas ang ating boses dyan. And our desire to review, of course. So here's the second question. A rectangular key was used in a pulley connected to a shaft with a power of 7.46 kilowatts at a speed of 1,200 RPM. If the shearing stress of the shaft and key are 30 and 240 megapascal respectively, what is the shaft diameter? So I'm going to draw a simple drawing for this. Now we have a rectangular key here. Now was used in a pulley connected to a shaft. So ibig sabihin, ito yung shaft. At syempre, andyan yung pulley mo. Alright, kunyari, bilog, no? Kunyari lang naman. So, here's your key, here's your shaft, and of course, here's your pulley. Ang sabi, no? Ang sabi, ang rectangular key was used in a pulley connected in a shaft with a power of 7.46 kilowatts. Sabihin natin 7.46 kilowatts na power at a speed. So kunyari meron tayong speed dito na 1,200 RPM, which is N is equal to 1,200 RPM. If the shearing stress of the shaft and key are 30 and 240 megapascals respectively, so the shearing daw is 30 sa shaft, and sabihin na natin ang key is 240 megapascal. What is the shaft diameter? So we're looking for the diameter of this shaft. Sabihin na natin siya ay D. No, ito yung shaft natin. Ayan. So how are we going to do this? We're looking, or the question is looking for the shaft diameter. No? And we all know that we can find the diameter under the torsional stress problem, which is torsional stress is equal to 16T divided by pi d cubed. Okay. So, meron ang hinahanap natin is diameter. Of course, we have stress here, dalawa. Isang for shaft and isang for key. Ang problema, meron ba tayong torque? So, based on the problem, walang given na torque. Pero good thing we have the power here and we have the shaft speed here. So kabisado na natin to. Kapag given yung power and speed, we can find the torque, which is power is equal to torque times speed divided by 9.549 times 10 raised to 6. Given that your torque is in Newton mm, your speed is in RPM, and your power is in kilowatts. So ayun, sakto ang bigay. Meron tayong 7.46 kilowatts is equal to torque multiplied by speed 1, 2 divided by 9.549 times 10 raised to 6. So our torque here will become 7.46 times 9.549 times 10 raised to 6 divided by 1,200. So we have a torque of 59,362.95 Newton mm. So expect that torque is not large as much nung mga previous samples kasi we have a small power which is 7.46 kilowatts only. So ayan, meron na tayong torque. Pwede na nating makuha yung diameter here given yung stress. So ang tanong dito, anong gagamitin nating stress? So no need to compare both stress kung ano yung mas mababa or mas mataas na diameter. So simply on this problem, we're going to use na yung shaft directly. Bakit? Kasi yung torque sa shaft nagaganap. Hindi and yung power sa torque the torque, the shaft speed, of course, nagaganap sa shaft, hindi naman sa key. So we're going to use this 30 megapascals na. So 30 megapascals or Newton mm squared. Newton per mm squared is equal to 16 times 59,362.95 divided by pi d cube, which is pi d cube. Ayan. So, unknown pala yung diameter nga pala. So, matik na to. If your torque is in Newton mm here and your shearing stress here is in Newton per square millimeter or megapascal, matik yung makuha mong diameter is in millimeter. So, ayan. Huwag mo naburahin yung answer mo sa torque. 16 times answer divided by pi times 30 mo sa ilalim. So, get the cube root. So, the answer is 21.6 mm. So, to those who are asking, ano yung mga pinagbabanggit kong mga numbers, syempre ito yon. Tapos may times, may divide kasi nasa isip ko na kung paano siya mas mapapadali. No, pero you can use also the shift solve, no? Pwede naman, wala namang problema doon. Pero ako nagko-cross multiply lang naman kasi ako, no? Kaya yun lang naman, ganoon lang kasimple. So the answer is 21.6 mm. So meron ba tayo sa multiple choice? A 23.6, B 21.6. So ito agad sakto. So the answer to this second question is letter B. Okay, so proceed tayo sa third question. So pag tiyagaan nyo na yung naririnig yung tugtog, no? Ewan ko anong trick nila, pero tuloy lang tayo sa pag-solve. A 76 millimeter solid shaft is to be replaced by a hollow shaft of equal torsional strength. So determine the percent saving in weight by using hollow shaft. The outside diameter of the hollow shaft is 100 millimeter. So here's the scenario. We have a 76 millimeter solid shaft. Sabihin na natin solid shaft yan, kunyari bilog, which is ang 76 mm daw ang diameter. So sabihin na natin is equal to ds or solid diameter is to be replaced daw. O pangit ng arrow natin, no? So ganito na lang. Is to be replaced daw by a hollow shaft. Sabihin na natin ito yung hollow. So pag sinabing hollow, butas, may inside and may outside. So ayan, lagyan ko lang ng guhit. Ayan. Is to be replaced by a hollow shaft of equal torsional strength. So determine the percent saving in weight. So I will draw first, no? Determine the percent saving in weight by using hollow shaft. So the outside diameter of the hollow shaft, sabi ang outside daw, sabihin na natin DH is equal to 100 mm. And of course, if may DH na malaki, meron tayong DH din na maliit. So ang hinahanap is the percent saving in weight. Kasi nga, itong 76 mm na solid shaft ay pinalitan mo ng hollow shaft of equal torsional strength. Ngayon, hinahanap kung ilan percent yung natipid sa timbang by using hollow shaft. Then we all know na mas magaan to kasi nga mas butas. Ang problema, mas malaki yung outside niya, which is 100 mm. Okay? So, paano natin gagawin to? So, meron ding given na condition of equal torsional strength. And we all know that torsional strength is also the torsional stress. And we all know also that the torsional stress is the torsional stress of the solid shaft is different from the torsional stress of a hollow shaft. We all know, no, na kapag sa solid, gamitin lang natin S. Sabihin natin SS ng solid is equal to 16T over pi d cube, no, ds. And sa hollow naman, alam natin na it is 16T dh over pi dh raised to 4 minus dh raised to 4 na mali. And if this is to be equal, sabi, so kailangan natin siyang i-equate. Okay, so equate natin. So anong yung mga maaari natin i-cancel? So of course, the constant of 16, syempre yung torque din. Kasi wala namang sinabi, and equal torsional strength means equal din yung torsion mo. Of course, we can cancel this pi also. Okay, so ayan. Ang matitira is ito, 1 over ds cube. So our ds is 76 cube is equal to dh, which is 100. And dh raised to 4, 100 raised to 4 is equal minus dh raised to 4 na maliit. So our inside diameter of the hollow, so Ang purpose pala nung equating these two torsional stress, no, is to determine the inside diameter. So makita natin mamaya kung bakit kailangan hanapin. So 100 times 76 cube minus 100 raised to 4. Siyempre negative yan, times negative mo lang para maging positive. And get the fourth root. So our small diameter of the hollow is 86.55 mm. So just check lang ulit. So kaya ako nagpo-cross multiply, guys, kasi nga halimbawa yan raised to 4, kapag sinipsolve mo yan medyo matagal sa calculator. So just need to review our algebra, no? Mga ratio and proportion, tsaka yung mga cross multiply. So ulit ko lang ulit. So 100 times 76 cube minus 100 raised to 4 times negative 1. Then kunin mo yung fourth root. So that was 86.55 mm. And lumabas naman that it is lower than 100. So basically, this is correct. And of course, ayan, hindi pa yan yung tanong. Ang tanong is determine the percent saving in weight. So how are you going to find the amount of percent saving in weight? So lagay natin percent saving in weight. Okay. So para malaman natin yung percent saving in weight, of course, we need to know the difference of two weights. Okay, sabihin na natin weights of the shaft, the solid shaft, minus weight of the hollow. Kasi nga, kailangan mauna si shaft dito kasi mas mabigat siya kasi nga solid siya. Ito, butas. No? Siyempre, kapag para malaman natin yung percent saving, kailangan yung denominator mo is yung original mo, which is WS. Parang ganito lang yung concept niyan. Yung 100 pesos mo, naging 100, sabihin na natin, no. Yung 120 mo, sabihin natin. Yung 120 mo, naging 100. So, magkano yung natipid? So, syempre, pag tinignan mo yung numbers, ang natipid is 20. So, ilang percent yan? So, 120 minus 100. Diba? Naging 120. So, that was 120 minus 100 divided by 120. Tama ba? Okay. So, 120 minus 100 minus 120. Ibig sabihin, ang natipid daw is 16.67%. So, parang ganun lang din dito. The difference, no? Ibig sabihin yung natira divided by the original weight. Parang ganun lang naman yung concept. Okay? Parang nangyari, ulit, isa pang scenario, meron kang 100, naging 50, matik naman, nabawasan ng 50, parang nangalahati, ibig sabihin 50%. So, kunin lang natin yung difference niya and of course divided by 100 which is your original. So, 50 over 100, so that was 50%. So, parang ganun lang din dito yan. Ay, sorry. Excited tayo mag-proceed sa next question, no? So, ayan. So, proceed tayo. WS minus WH divided by WS. S for solid, H for hollow. So, ano nga ba ang formula muna ng mga weights? So, alam natin, ang weight ng material is equal to specific gravity ng material times the volume. So, parang wala nang pinagkaiba yan sa density is equal to mass times volume. Tama ba? Tama ba? Mass is... No. Walang pinagkaiba yan sa mass is equal to density times volume. Kasi alam naman natin that weight is equal to mass times gravity and specific gravity is equal to density times gravity. So parang ganun lang din yan. So sa material, ganyan. And we all know that volume is equal also to area times length. Lalong na-given yung cylinder or kung meron kang shaft dyan. So this is your area. So this is your area and this is your length. Okay, palitan ko lang to, medyo pangit yung A. So, ganyan lang. So, that was specific gravity times A times length. So, our percent saving in weight is equal to WS. So pag WS, lagyan natin ng ganyan. Specific gravity times area. Lagay natin S, solid, times length. A minus specific gravity times area ng hollow times length ulit. And of course, the WS, which is specific gravity times AS times length. At kapag wala namang sinabing length na amount, so matic, equal siya. And wala rin namang sinabing magkaibang material. So, ibig sabihin, si specific gravity here is equal to both of the shaft, both hollow and solid. So, pwede natin cancel ito, cancel ito, cancel ito, cancel ito, cancel ito, cancel ito. So, puro area na lang din ang matitira. And we all know that the formula for the area of both material is equal to pi over 4. May involved na pi over 4. So, kung si solid, pi over 4 ds squared 8, ds squared. Binubura ko lang magkakadikit. No? And we all know that the hollow is bakit ang sulat natin? So relax lang, wag magmadali magsulat. So we all know that area for the hollow is pi over 4 dh squared minus dh squared na maliit. So basically, meron kang pi over 4 dito, may pi over ko sa ilalim. Delete na natin yung pi over 4 para hindi na tayo occupied sa pagsusulat. So our area for the solid shaft is ds squared na lang minus hollow, which is dh squared minus dh squared na maliit divided by ds squared. So our percent saving in weight will become ds squared malaki ay sa solid, which is 76 squared minus dh squared ng hollow, which is 100 squared minus dh na maliit, which is 86.55 squared divided by 76 squared. So the equivalent is 76 squared minus parenthesis 100 squared minus 86.55 squared divided by 76 squared. So overall, the percent saving in weight is 0.5656 times mo lang 100%. So that will become 56.56%. So the answer is 56.56. And ayun, meron agad tayo sa letter A. So the answer is the letter A. And if guys, just a little technique, hindi naman natin din kailangan mag-analyze isa-isa sa problem or sa board exam kasi medyo bilang nga o limitado ang oras doon. So ang pinakamaganda doon, so kung hindi mo naman sa kinakabisa, no? So kung na-review mo naman, why not? So kung nakakita ka ng ganitong problem, so lagyan mo agad nito. Sundan mo na lang agad yung formula nito. So lagyan mo lang area nung shaft, area nung solid minus area nung hollow, divide mo lang ng area nung solid. Okay? Or vice versa, kung pinalitan man si hollow ng solid. Okay? So, ganun lang naman. Pero syempre, be careful din sa pagbasa ng question. Baka mamaya may trick pala or iba pala yung So, just a little advice lang naman. So, that was our third question. So, punta naman tayo sa fourth question. The shaft of a motor has a length of 20 times its diameter and its limiting angle of twist is 1 degree under a torque of 2 kilonewton-meter. If the modulus of rigidity of the shaft is 80 gigapascals, find its diameter. So the question is looking for the shaft diameter, given that the length of the shaft is 20 times the diameter daw. So sabihin natin 20 times diameter. So let D the diameter of the shaft and its limiting angle of twist is 1 degree. Sabi 1 degree daw under a torque of 2 kilonewton-meter. So I'm going to multiply by 10 raised to 6 na ito in order for this to become in Newton millimeter. So that will become 2 times 10 raised to 6 Newton millimeter. If the modulus of rigidity of the shaft is 80 gigapascal, so times na natin agad to ng 1,000. para maging megapascal. We all know that 1,000 megapascal is equal to 1 gigapascals. And remind ko lang ulit that 1 kilonewton meter is 10 raised to 6 newton mm. So kataon parang ano lang yan, 1,000 times 1,000 kaya naging 1 million or 10 raised to 6. Kasi 1 kilonewton is 1,000 newton and 1 meter is 1,000 nm. So ulit 1,000 megapascal is 1 gigapascal and we need to convert it to megapascals because megapascals is newton per square millimeter, no? And meron tayong newton dito para hindi na tayo mag-occupy ng space dun sa formula mamaya. So it will become 80,000 megapascals. Okay. So ayan, nasulat natin lahat ng given, find its diameter. So since this is an angle of twist problem, we all know the formula of angle of twist is equal to theta is equal to TL over JG. May torque ka, may length ka, may modulus of rigidity ka na G, and meron kang J which is the polar moment of inertia. And we all know that the polar moment of inertia is equal to pi over 32 times d raised to 4, basta solid. And ayan, given naman lahat, and I think this will become a direct substitution. So our theta is 1 degree or angle. So alam naman natin na ang answer should be in radians. So convert muna natin to sa radians. We all know in every pi radians, meron tayong 180 degrees. No, kung meron tayong 2 pi as 1 revolution, that was 360 degrees, syempre. Kung meron kang pi in every 180 degrees. So, pi over 180 degrees, pi radian is equal to torque, which is 2 times 10 raised to 6 Newton mm, r times the length, which is 20 diameters daw. Ayan, in terms of d. And of course, the polar moment of inertia is pi over 32 d raised to 4 times g, which is 80,000 megapascal or 80,000 newton per mm squared. So ano ba yung mga pwede nating i-cancel? So dito wala tayong unit kasi radians na siya. So cancel si newtons here. So may square millimeter ka, it will be multiplied on the above millimeter. So it will become cubic millimeter. No? So magtataka kang bakit 3 lang, meron kang d raised to 4 dito. Take note that the length is given in terms of diameter. So cancel na natin tong d at isang d dito. So magiging cube siya. So kung ano yung magiging answer dito, in cubic millimeter, of course, take the cube root. And of course, our end unit is in millimeter. So our diameter, dito ko nalalagay yung diameter, will be equal to, okay, so 2 times 10 raised to 6. Okay guys, hindi nyo man kailangan gayahin yung ginagawa kong technique kung saan kayo mas komportable. If you are comfortable doing the shift solve, why not? But I'm just doing the yung isa-isa. Kasi minsan may nadidiscover akong sagot hanggat di ko pa tapos i-compute lahat. Parang gano'n lang naman yung principle, but no need to copy. It's up to you. So 2 times 10 raised to 6 times 20. Itaas ko na si 32. Tapos iwan ko si pi sa baba times 80,000. And syempre si 180 degrees pupuntang taas. Tapos si pi uli sa baba. Of course, cube root ng answer. So my diameter is 66. So my answer is 66.32 mm. Yeah. 66.32. Wait, 33 pala. But it doesn't matter. 66.33 mm. So meron ba sa choices niyan? We have A 36.6, B 66.3. So yan yung pinakamalapit na answer kasi dalawang line of 5 agad dito. So our final answer is letter B. So the answer is letter B. Okay, so we're on the last question for the part 2. No? So I will read the question first. A marine propeller shaft is to transmit 3,700 kilowatts, no, ang laki, at 126 RPM without exceeding a torsional stress of 42 megapascal or twisting through more than 1 degree in a length of 20 diameters. The modulus of rigidity is taken as 83 gigapascal. Find the required shaft diameter. So the answer or the question is looking for the shaft diameter. So meron daw tayong marine propeller shaft na nag-transmit ng 3,700 kilowatts. So napakalaki niyan, no? Napakalaking barko siguro niyan at 126 RPM. So mabagal, no? Siguro dahil sobrang bigat o ang laki ng tail shaft. So ayan, nakakita tayo agad ng power and shaft speed. So matik may torque yan mamaya. And without exceeding a torsional stress daw of 42 megapascals. Or twisting through more than 1 degree daw. In a length of 20 diameters. So the modulus of rigidity is 83 gigapascals. So times na agad natin ng 1,000 or 83,000 megapascals kasi kailangan natin naka-newtons lahat. So find the required shaft diameter. Yan. So here's the thing, guys. Hinahanap natin diameter kaso dalawa yung given, which is the stress and the angle of twist, which we know that the stress is equal to 16T over pi d cube, meaning pagkakuha natin ng torque dito sa power and the shaft speed, we can solve the diameter here. But one thing is meron ding given na angle of twist, which is alam natin that is equal to TL over JG, and pwede natin makuha dyan yung diameter by means of the polar moment of inertia, which is J is equal to pi over 32 d raised to 4. So ang tanong, Sir HB or Engineer Hayson, ano ba ang diameter na i-accept natin? So ang i-accept natin, of course, yung mas mataas. Kung ano lumabas na diameter dyan at kung sino mas mataas, piliin mo yung mas mataas. Bakit? Kasi it is inversely proportional to the stress. Ibig sabihin, kapag niliitan mo yung diameter mo dito, tataas yung stress mo. So lalagpasan mo na yung allowable stress, which is 42 megapascal. No, sabi nga, 'di ba, without exceeding. Ayan, without exceeding. Pero kapag nilakhan mo yung diameter mo, of course, liliit yung value ng stress mo. Ibig sabihin, hindi ka nalalagpas sa stress. So we're going to solve both diameters for this scenario, and kung sino yung mas mataas, yun yung answer natin. Okay, so unahin muna natin si stress. So ang stress is 42 megapascals. So alam na natin unit analysis dyan. Is equal to 16 times torque. So kunin muna pala natin yung torque dito. And we all know that the power is equal to torque times shaft speed divided by 9.549 times 10 raised to 6. Basta ang power mo is in kilowatts. Ang torque mo is in Newton mm. Newton mm, and shaft speed mo is in RPM. So our power is 3,700 times 9.549 times 10 raised to 6 divided by 126 RPM, and the answer is makalaki. 28 million. So try ko lakihan yung mga sulat ko, no, kasi baka hindi nakikita ng iba. Kaya that's why we need to follow one by one. That's not 28 million, that's 280 million. 407,142. Ganun kalaki. 0.9 Newton mm. So napakalaking barko nito, no? Kailangan ng ganyang kalaking torque para mapaikot yung shaft mo or yung tail shaft mo. So 16 times torque, which is 280. 407,142.9 divided by pi d cube. Ibig sabihin, pwede na natin kunin si d cube or si diameter. So that was. Ang technique dito, guys, since we're going to get the torque again on the angle of twist, so itago nyo na yung torque, shift store A nyo na. para hindi na tayo mag-type mamaya o mag-compute pa mamaya dun sa angle of twist. So it will become 16 times the answer times pi sa ilalim times 42 sa ilalim. Cube root mo yung answer. And it is 323.97 millimeter. Okay, so proceed naman tayo sa angle of twist. Kailangan malaman muna natin to and to compare which is higher diameter. So angle of twist. So lagay ko lang dito, idikit ko lang. So our angle of twist is equal to TL over JG. So ang angle of twist natin is 1 degree uli. Okay? So times pi radians divided by 180 degrees kasi kailangan naka-radians is equal to torque. So lagay ko na lang torque, no, guys, kasi masyadong mahaba, no? And shift store mo na lang sa A yung value kanina. Kasi alam naman natin na kailangan naka-Newton mm yan, which is Newton mm na may nakuha mo rito. Shift store A mo na lang. Times length, which is 20 diameters. And the polar moment of inertia is pi over 32 d raised to 4. So dito pa lang cancel na yung isang d. So d cube na lang yung matitira. Times the modulus of rigidity, which is 83,000. So our diameter will become, so again, no need na gayahin nyo yung pag-solve ko ng cross multiply. Para madali lang na yun, just cross multiply. You can shift solve this. You can shift solve all of our sample problems. Okay, so our torque na naka-shift store sa A times 20. Taas ko na si 32. Iwan ko si pi sa ilalim times 83,000 sa ilalim. Tapos may pi pa sa galing sa theta, which is nasa denominator here. And 180 degrees pupunta sa taas. Of course, we have d cube. I-cube root ko yung answer. So our answer is 340.37 mm. So which is bigger? So ayan, syempre 340.37 is greater than 323.97, which is nasa answer naman. Tama ba? So ayun, 340.38 mm. The answer is letter B. Okay, so ganun lang. Pag nag-compare ka, kailangan laging hindi lalagpas sa allowable stress mo. Hindi, syempre lalagpas yun. And kita mo naman yung 323.97, obviously wala naman sa choices. 324.26 yung pinakamalapit. Pero lumabas sa tawas, 340.37 at meron naman pinakamalapit dito, which is a decimal lang naman nagtatalo. That's the correct answer. So ayun lang guys, salamat sa pagsama sa part 2 ng ng shafting. And we're going to proceed with the next video, which is the part 3 ng shafting. Siyempre, di-discuss natin doon yung mga power, no, doon sa machinery handbook, andun doon yung combined stresses, and siyempre andun din yung mga shafting due to its own load, and so on and so forth. So salamat sa pakikinig. Good luck guys sa inyong review, and of course, don't forget to subscribe sa ating channel. Libre naman ito. And sa ating page na rin sa Facebook. Salamat sa pakikinig and see you on the next videos. Bye!